the mass moment of inertia, or I can say this is the final topic in this unit number 3. Name itself says mass moment of inertia. So here I have drawn one sketch, right, to show the formulas. So before going to this formula, I'll just say, suppose a lamina, a plane body is there. The purpose of studying this mass moment of inertia is that, aim is that to determine the moment of inertia of a body with a mass m. Say for example, this is my axis A. I have a body with elemental area d, dA small. The distance of this is r. Okay. With my m is the mass of the body. Mass of the body. Till now we have determined the moment of inertia without considering the mass. If we are considering the mass of the body to find out the moment of inertia, by having a particular distance of that, any element will have a particular distance from an origin point O. That distance taken is here r. Now here the consideration is, we have to consider that or assume that if suppose this element is being rotated, okay, this element is being rotated in a direction by fixing the axis as AA, or the axis AA is a axis, fixed axis. Surrounding, around that axis, if this element is rotated with a radius of r, then how do we write the moment of inertia for this? By considering the mass also. That is given as I of AA, moment of inertia, with here dm A is mass moment of inertia, is this r value, its square, because again it is second moment of inertia, into dA. Meaning is, a small element is being integrated, that is next step, but it is assumed to be rotated by fixing the axis AA constantly with the radius of r. The square is written because it is second moment, right? So finally this will be integration about the total A, and it is r square dA. This is basically called mass moment of inertia. It is moment of inertia, finding moment of inertia. Purpose is to find out moment of inertia with an elemental, the element with a mass m, right? Now here, same step. See, every step in the third unit is from the beginning finding center of gravity. You will have a set of sketches, plane figures or solid figures. You will have a formula for x and y values and area also. That you have to implement. The procedures are same, but every step. Only thing is you have to remember the formulas. For example, here mass means, I have just given this is an isometric view which shows that a rectangle box. Is it not? This rectangle box, it shows the x-axis axis is this. Say, x-axis axis is here and y-y axis is here. And the base line is called AB line, and this is BC line of this rectangle. And your breadth B is shown, bottom is breadth B, okay, and this B and no, this is not B, this is D, BD, okay, this is D and this is B, right? So center of gravity CG with respect to x-axis axis, y-y axis, as well as z is that axis. What is z axis? It is normal, perpendicular to the plane of the figure. Z axis is been determined with this set of formulas. How is that? Ixx is in terms of the amount of the mass present in the body. How do we write this mass? A formula is given. Mass in the sense, m is rho, density of the body. The value will be given, because anything, this body will be filled by the material. That material have some density value. Okay, that like it is rho, and B is breadth of the body, D is this depth D, and T is thickness of the body. This will have a small thickness. This is thickness T here. So this mass is been determined by these parameters: density, breadth, and depth, and thickness. Okay, and this Ixx value will get by like this. Here only the d square by 2. Why this d? D is here. Xx value is been got because x is this base, right? And the perpendicular distance for this x is this d only. Am I right? What I am telling is, rectangle is like this. My xx axis is here. This is my d. Is it not? Moment is what? The the perpendicular distance only. This is my d actually. X axis goes going towards here. So if I get xx, it's m into d square by 12. For yy, m into b square by 12, because yy axis is this. For this yy axis, what is the perpendicular width? It will be b only. B is measured because y is acting like down. Yy, this b breadth b will be my perpendicular line like this. So this is m into b square by 12. Then zz axis, m by 12, this same thing, into b square plus d square. That is, your multiplication of xx and yy will give you the z values, because z is perpendicular to both x and y. That's what the consideration is. It is 90 degrees to both here, both 90 degrees. So b square plus d square. Then you have IAB. This AB is a base reference line. Though you have xx and yy and zz, three different reference axes or lines, you have a baseline AB and BC depending on the sketch. If you go for a circle, it will be different. Quadrant will be different. Semicircle is different. That's available in the book, the formulas as it is. So IAB is m into d square by 3. IAB, this is AB. Again d, because for AB line axis, d is a perpendicular distance. No, 90 degree distance. Like this it is. Is AB is here. This is your d. Okay. IAB, m into d square by 3. IBC, what is the BC here? BC is this line. For BC is this line. So your B will be the perpendicular distance. Since BC in this fashion, BC is here, then the breadth B will be perpendicular 90 degrees. So IBC is equal to MB square by 3. So with these formulas, the applied values, directly you can apply and get the values. Right. So one problem you solve with this, be easy. So mass moment of inertia aim is to find out moment of inertia of a body by considering its mass also. Okay, that is mass moment of inertia, and this set of formulas will help good for finding out answers. Remain the procedures are same. So from the beginning, unit number 3, start center of gravity, then you go for moment of inertia, then it is your polar moment of inertia, radius of gyration, and step by step. Everywhere you have some set of formulas. It's a confined formula, defined formulas with the sketches that you have to remember and implement. But very important is the unit. Moment of inertia in the sense it has to come mm power 4. Okay, millimeter or millimeter power 4 or square. That you have to remember it. Then 2 or 3 problems you have to keep on solving 1 or 2 times, because the calculations you will miss it by sign convention also. That is very important. That if you take care, 2 or 3 problems you practice, you will get the answers. No doubt in that. Okay. We have seen about moment of inertia basically. What is moment? The moment of inertia. Then we have seen center of gravity, all these things. And we have seen 1 or 2 problems, you have to solve it. And in every step we need to find out center of gravity. Then we go for moment of inertia with the available formulas in the book. The shape, area, x and y values given in the book are very important, you have to remember it. The next step is, after this moment of inertia, we have got one topic called principal moment of inertia. And basically we are studying about the product of inertia here. Product of inertia is the one we are studying under this topic. See, the name itself is says product multiplication, which I told you in the last class, a summation of x and y values with the area. This to just define this. Suppose you consider a body, any body it is, we will have x and y axis basically to know a plane, and suppose I have a small element whose area is dA. From an origin point, okay, from the axis, I will be always having a coordinates of x and y values to define that particular element is at what distance. We will have to define this element by giving a value of x and y, right? So this distance I take it as your x values, so this is x coordinates, and this distance will be your y values, y coordinates. So here in product of inertia we are going to multiply the values of your x and y, ixy, which means we are considering the elemental length, okay, a small xy value of this coordinates, xy coordinates, for elemental length, and we again integrate with respect to the total area. Product means coordinates of x multiplied by coordinates of y. That's the meaning here. So here the elemental length will be normally given very small value, and finally we integrate with respect to the total area A for any body which is considered. So finally we'll get the product of inertia values. This is the main purpose, and here we have a few set of conditions to solve any say problem under this topic. First condition is product of inertia we are finding out product of inertia to find the maximum and minimum values of inertias. Product of inertia is method used for finding out the maximum and minimum values of inertia, or minimum inertia can say, maximum value inertia values of inertia, and this in turn is called your principal moment of inertia. Moment of inertia, right? This product of inertia we are finding out through this. Consider a small element at some distance from the origin point with x coordinates, y coordinates. That is you are just multiplying the x and y, the small elemental area, and finally when you integrate with respect to total area, you will get product of inertia, this ixy. Okay, it's called product of inertia pi or ixy, multiplication of x and y coordinates. And after that, the conditions when we solve a question is that actual aim is we are finding out maximum and minimum values of the inertia here. This in turn is called as principal moment of inertia, right? And second point, for any plane figure, that means we have circle, rectangle, triangle, whatever it is, that figure, if it is symmetrical about any axis, in the sense, suppose I draw a figure like this, sketch like this, it's called I section. This is an I section. I have another figure, a T section. Okay, one more, whatever it is. Or I have another section which is an inverted, kind of C section, whatever it is, depending on the plane figure. These sections you can write as per if you want to show a symmetry in any axis. This section is symmetrical about both the axes. What I meant to say is y axis and this is x axis. Is it not symmetry? If you fold through x axis direction also, it's equal, mirror image. Or if you fold through y axis direction, it's also a mirror image. So this section is symmetrical about, I'll write symmetry about xx comma yy. What about this section here? This is symmetrical about only y. If you fold in y direction alone, it will be symmetry equal. If you go to x direction, it will not be equal. This is symmetrical about y axis. And this one, this is not symmetrical about y axis, only about x axis. Is it not? When you fold it only x direction alone, this direction alone, it will be symmetry. So this is symmetry about xx direction, xx axis. So the product of inertia for any plane figure, if it is symmetrical about either both the axes or for one axis or other axis, it cannot be found out. This answer is 0. The meaning is, this product of inertia denoted by symbol I, Ixy, or I can unite IP also, this is value is equal to 0 for any plane figure which is either symmetrical about one axis like this or this, or symmetrical about both the axes. This is one important condition, right? So the next condition is, the second condition is, you take any plane figure or an elemental body, there are set of rules to, or I can say it's a sign convention to say that at what direction, either it is towards right side of an axis or left side of an axis, is it above the axis or below the axis. Based on that, the sign conventions of the product values varies. Say for example, I'll just take a quadrant. The first quadrant, second, third, fourth, right? Consider an elemental area, small value, this is A, dA, small element, in all the 4 quadrants, dA here, okay, dA here, dA here, is it not? So this will be your x value, x coordinate value, this will be your y, for this is again x, y here, this is x, and this distance is y. Is it not? Then this is again x distance. I am just drawing a rough sketch, okay? You will have to understand what is this. This is y. So what I can say is, this is to define, this is an y axis, this is x axis. If an elemental area or if a coordinate is right side to the y axis, the values are taken as positive. If it is left side to the y axis, the coordinates are taken as negative value. Can you understand? For this elemental area 1, how will I write? For dA1, say this is first quadrant, no? dA first quadrant. The x value is positive, I say x1 is positive. It is plus x1. Okay, and y is, first I was talking about only x to the right, plus x. So the right side values are positive, and left of y is negative, then above xx directions are positive, below xx directions are, values are negative. So for the elemental area 1 plus x1, comma, what about y? y1 is above x, so it's plus y1. Hope you get it. Xx axis and y axis, xx and y axis. The product of inertia is calculated in terms of sign convention, basic sign convention, which says that any coordinate which is right side to the y axis is positive, left side to the y axis is negative. Above the x axis is positive, below is negative, right? So for this first quadrant I am writing x1, 1 means first quadrant, y1 is first quadrant. So x is right side to y axis, so it's positive. And y is above xx axis, so positive. Then when you write dA2, second quadrant, x is becomes left side to y axis, so it's minus of x2. So I'll write here 2. So to avoid confusion, x1, y1, x2, y2, x3, x3 distance and y3 distance, okay, and x4 and y4 distance. So dA2 is minus x2 because left to y axis is x2. What about y2? Y2 is above, so it's positive, comma plus y2. dA3 coordinates I'm writing. What about 3 here? X value is left of y axis, so it's negative x3, comma, what about y value? Y is also below x axis, so negative y3. Finally dA4, that is for fourth quadrant. What is the x value here? X value is right again. You need not confuse. X value is right side too, because x direction is this. So x is right side to y axis, so it's positive plus x4. And what is what y? Y is below x axis. Y is this direction, below x axis, so it is negative. Negative y4. So these conditions are very important, which means when we solve a question, any sketch, the basic idea is if you have any symmetry either of x and y or to both the axes, you can directly write product of inertia is 0. The next thing is, using sign convention, we have to decide the value of that particular coordinate while calculating is positive or negative based on where it is situated. Either it is right side to the y axis, fully positive, left of y axis, whatever it is, negative. I am talking about the x coordinates, because x is only, you are talking about right, and left is about x values, and above and down is of y, because you are traveling towards the vertical direction. So above x axis the y values are positive, below x axis the y values are negative. Clear? So with this 2 or 3 conditions, one problem if you solve it, 1 or 2 you can understand. So the procedures are same. You need not forget, any problem you solve under product of inertia, the purpose is this: to find out the coordinates of value, then finally multiply with your Ixy formula. Okay, we are finding out product of Ixy, x and y values. That's it. That we see one problem. So here is a simple problem given, right? So just find out the Pi means product of inertia. Find the product of inertia coordinates, it is x and y values, of the composite plane figure. Composite in the sense, more than one sketch, one different sketch become composite. So here there are 2 different sketches are given. About sketch number 1, if you see this, what is this given here? I'll take the first portion as a rectangle. Second one, I'll go for this as a triangle. And the third one, here, this is a quadrant. Is it not? It's a quadrant. Now, this sketch, the value of x axis, xx is here. Okay? That means the total body is sitting on x axis, and y is this direction. The difference is y is at the edge of this rectangle. After y to the right hand side of y you have a sector as well as the rectangle. Xx is fixed at the base. So the total sketch is above x axis. Now we have to write the product of inertia coordinates for this composite plane figure. What is coordinates means? With the sign conventions what we have seen previously, what are the x and y values? Say x1, we will instead of to avoid confusions we will take x1 dash, y1 dash, etc. In the meaning for the first sketch, say suppose rectangle, this is a rectangle, okay, you need to write your x and y values. What do you mean by x and y values? Actually, x is the centroidal distance of the CG from the reference axis for individual figure. That's what we learned first. In the beginning of this chapter I have told that there are number of sketches, you have x and y values, for that we have formulas. Say suppose the rectangle means to find x or x, so the value is length by 2. And again I have to write this rectangle, in order to make you remember. This rectangle is L, it is B. To find x value you should write L by 2. Mean y value to find B by 2. Breadth by 2 and length by 2. The same thing holds good here also. But we have to specify here, if it is as per this is condition product of inertia, if it is left side to the y axis, it becomes negative. Right side to y axis is positive. The value of x and y will become positive. But what is x and y? It is the centroidal distance from the reference axis to that particular body CG, center of gravity. Because every section shape will have plane figure will have its center of gravity. This CG for this, say suppose the center of gravity for this, quadrant is this one, and for rectangle is, suppose CG is here. And triangle. This triangle is it is an inverted one. Normally you can write triangle either like this, okay, or you'll be writing like this, or even write isosceles triangle. But this triangle is just inverted of this right angle triangle. That is, it is kept in this fashion. Is it clear? So the bigger end is this and smaller end is this. We have already learnt, if you are writing for this x values as per the formula given, if you go from the bigger end towards the smaller end, it is 1 by 3 into this length. This is length here, and height is this. Hope you can imagine how it is. If you tilt it, whatever it is, the bigger end, this is the bigger end, the total height is bigger end, this is the smaller end, is it not? So when we are calculating the x and y values, x means always with respect to L, it is like this, L. So 1 by 3 of L will give you the x value here, right, to find the CG, center of x value, if you are traveling from bigger end to smaller end. And if you want to go from smaller end to upper end, bigger end, it is 2 by 3 of L, right? There is the idea here. That we'll see. Now here, for that, so for this rectangle, how do we write? You have to write the values of x and y. Here I will take it as x dash and y dash. So I am writing x dash for this rectangle alone. Normally, rectangle x to find out L by 2. This is my length L. What is the value given? 20. It is 20 by 2. But is it actually 20 by 2 only? I am finding out the CG, center of gravity, in x direction from the reference axis is y here. I am traveling towards x means either towards right or left. This is x direction. Okay. So x direction here from y reference axis, the x values are left side of y. What is the meaning? It should come negative. Value is 20, but that is minus of 10 meters. Is this clear? This is the value. This is my x1 dash coordinate or coordinate x1 dash for this particular first figure, question number 1, x1 dash value. Same figure, y1 dash value. What is y1 dash here? Y means from the base xx axis, wherever the axis may be here or center, wherever it is. From where it is given in the sketch, from there you travel towards y direction. What is y1 dash here? For this one, as per the formula, y means it's b by 2. I am writing the formula of the basic first starting point of this chapter topic of this unit. Same b by 2. Breadth is this. What is the breadth here? 25 plus 15. It's 40. It's 40 by 2. What is sign convention here? The answer is 20. You can write it. What is sign convention here? It's positive only because this y1 dash value is above this x axis. It is positive value. So x1 dash is clear, y1 dash is clear. 1 denotes portion number 1. 2 means portion number 2, rectangle, triangle. 3 means portion number 3, this quadrant. Okay. Now rectangle is over. I will just erase it because space. Then I will write for a triangle. Triangle. Actually, the shape of the triangle is like this. Here it is given like this. This becomes your L. Okay? Or smaller end, bigger end. From the smaller end, it is 2 by 3. So I should take this is L. Whatever the rectangle may be, L should be this. And this should be your B. Okay. Now x2 dash for this rectangle is, what is the formula for rectangle? It is 1 by 3 into L. Again, either 2 by 3, 1 by 3. L. It is height, length by 3, L by 3. So here it is 1 by 3 into L. What is 1 by 3? 1 by 3 value into L is what the value given? 25. 25 by 3. Whether it is positive or negative, I am going x direction. The x values are right side to the y axis, so it is positive, as it is positive. This is the value. Then y2 dash. Y is again traveling from lower to higher because y is vertical direction. So from here you travel to the top. Clear? What is this again? From lower to the higher land you are going. Right? It is 2 by 3 into this, but this is 15. That's it. Is it positive or negative? It's positive only because it is in the upper side. It's clear? This is 1 by 3 I am writing because from bigger end to smaller end, and this 2 by 3 is from lower to bigger one. That's directly you get the value. Is it okay? Then that's about the triangle. Then this quadrant. Quadrant shape is like this. The quadrant. Again the value is, this is 25 given, and this is how much? 25. Formula for quadrant, x dash, x1 dash, whatever it is. 4r by 3 pi is the x value from the given standard formula in the book. So x value. But whether we have to decide this value should be negative or positive is the question. Okay. What is this radius of this one? This radius is much, is 25 only. Here 4 into 25 by 3 pi. X value is right hand side because I am going to find out CG means x values means what? Traveling towards x direction. So this after yy it is in the right hand side, so it is positive. 4 by 3 pi. What about y2 dash? Y3 dash here. Again the formula is same, 4r by 3 pi. Y values are traveling up. It's again positive. What is positive here? Again 4 into 25 by 3 pi. That's it. That's how you write the coordinates. The meaning is anything which is left hand side to yy axis is negative, right hand side to yy, right of yy axis is positive, left of yy axis is negative, above x axis is positive, below x axis is negative. Clear? Now one more sketch I have written here just to differentiate the same sketch. I am just shifted this x axis to a distance at center 15 here. See, it starts from the 15 is total rectangle here. Just one shift of this x. What will happen here? Okay. Here what is this? Now for this, if you write CG for sketch number 1, this is rectangle. 2 is triangle. 3 is quadrant. For 1 you write x1 dash. How do you write this one? X is again traveling towards left or right? Left of this, so obviously negative. What is this value? Given as 20 by 2. Is it not? Then what is y2 dash? Y1 dash 20 and this is 40. Yeah, y is total 40 here. Then this 40. You are traveling up. But where is the xx value? The body is totally 40. Length is y. That is breadth b. It is b by 2 is the formula. This is l by 2. B by 2 here. This is 40. So 40 by 2 is the answer. But how do we write 40 by 2? 40 by 2, it is neither minus or not positive. It is half of the portion is above xx, half is below. How do you write it? Which means this 25 millimeter of 40 is above xx. That y value is positive. Below that is negative. How do you write? I take 25, this one, minus of 40 by 2. Clear? This is 25. This I am reducing 40 by 2. This value is this. Okay. This is x1 dash, y1 dash value. Then number 2 is triangle. How to write here? x2 dash, triangle again, 1 by 3 into this. What is this? 15. Okay. it's down below the, I'm sorry, this is x value, it is right side, so it's positive as it is. But when you write y2 dash, it is below the xx line, down it is negative 2 by 3 into 15. Then quadrant above xx and right side of yy is positive, 4r by 3 pi, as such whole square is positive. So by fixing the xx and yy axis, first we have to write the coordinates of this x and y values of x dash and y dash. After that, when you find out the, basically your center of gravity for x bar and y bar, with that values you can go for your product of inertia. The formula is what? Sigma a x and y, which means suppose you have a single body, you will find out x bar and y bar value, multiply with the area, you will get the answer. Okay. When you have two combinations, suppose you have the first problem what we solved in the simple center of gravity sketch, plane figures, is like this, an L section. This first one, this second one. What we do here? First we have to find out the x bar and y bar values, CG, center of gravity. After finding these x bar and y bar values, we have to decide, you will get yy and xx values, is it not? Then this becomes your CG. From yy and xx, based on this sketch, see, suppose this rectangle number 1, and half of this rectangle is left side to yy, which means whatever the coordinates I am fixing here will be negative. For example, you take just for consideration, when my x bar value after solving a1 x1 plus a2 x2 by a1 plus a2, I get a value, suppose say 11 millimeter. Okay, and my y bar value is some 11 in the sense this will be my 11, is it not? 11 millimeter x bar value. Y bar will be, say suppose my some 12 or 15, whatever it is, by a1 y1. These formulas we have seen already, so we will do it. A1 plus a2, we will get a value of suppose 12 millimeter, whatever it is. After this step, the x bar and y bar, we are going to find out the coordinates to find the product of inertia. This is ixy, is it not? What will you do here? This particular sketch with the value of x bar and y bar, clear? This is your x bar value, xx, yy. This is x bar and this is y bar, is it not? Values. To find out the product now here, the same case. Now your xx and yy is fixed. To go for the coordinates, depending on this is a rectangle. First rectangle, second rectangle. If I want to find out the center of this rectangle, what are the rules? I go for, this is L and this is B. Separately write, this is L, this is B. L by 2 value, suppose whatever the 40 or 50, I am just giving an example, that value. But this L by 2 is the individual centroidal, CG from this. But my reference axis is yy is here, which means it lies left side to the yy. So I will take it as negative. Say suppose this L is maybe some 20. 20 by 2, I should take it as negative because this individual center of gravity of this rectangle lies left side to yy axis. So in the same fashion what we did here for coordinate, when you find this, find out all the coordinates, multiply that and finally substitute in this equation. So this I am talking about x bar and y bar and area if you have only one sketch. Say suppose only one rectangle is there, I am finding x bar and y bar and finding out. But when my sketch is like this too, this can be modified as, just love this. So this equation, product of inertia, that is sigma a x bar y bar or xy, okay, will be sigma of a1, area 1, x1 dash y1 dash. That means you are finding out x1 dash for this and y1 dash for this. coordinate. X2 dash for this and Y2 dash for this. Same thing it is. Plus, I can write it like this: A2 X2 dash Y2 dash. Sorry, A2 X2 dash Y2 dash. That's it. Summation, you just multiply and get the answers. Kindly remember, this is IXY, that is product of inertia. You may get even answer in the negative sense. What is the meaning? Normally you will not get an answer for your X bar and Y bar negative answers, not required. It won't come. But here, product of inertia, you will get an answer finally negative, I mean to say negative some 11 into 10 to the power 4, 5 all millimeter to the power 4. Because mm per 4 is the unit. Centimeter per 4 or millimeter per 4 is the unit. You may get answer in the negative sense also. Why? Because depending on the coordinate setup from X and Y values. I told you by showing a graph, I mean kind of a plane figure with 4 quadrants. If the element is to the right of YY axis, it's positive. Left, negative. Above XX axis positive, below is negative. It's the same case here. You will get an answer of negative value here. You might get negative or positive, which means the element, the body lies left side to the reference axis. So 2 or 3 problems you solve with this book. Procedure is same. You have to implement, you have to write it 2 or thrice and see. Okay? When you do this, you will be thorough with this.